Okay, we are back with NASA astronaut Mike Fincke talking about the Kids in Micro-G Experiment Design Challenge. Mike, what should these experiments be geared for?
Well, Nathan, taking advantage of the small fraction of normal Earth gravity is the purpose of the Kids in Micro-G Experiment Design Challenge. We want our student scientists to take advantage of a unique aspect of microgravity that can't be duplicated in the classroom. Student scientists should devise an experiment that demonstrates a physical principle or physical effect which utilizes microgravity. The experiment should have an observably different result when performed by the astronauts on the ISS than when the student scientists perform the same experiment in their classroom.
Now, what types of physical principles should be considered when designing the experiment?
Well, principles such as the state of matter, Newton's law of motion, properties of mass and weight, the conservation of momentum, wave motion, surface tension of fluids, those are all excellent topics to consider. Student scientists should consult with their educators and review their class notes, textbooks, and the NASA educational reference material provided on this website to generate ideas for their experiment demonstration. The Kids in Micro-G website also contains a video clip of NASA astronaut Nicole Stott, my friend, demonstrating a physical principle not normally seen in 1G. I'll leave it up to the students and educators to determine exactly what principle Nicole was demonstrating. Nicole's video should provide some good food for thought, but we ask that the student teams not duplicate that particular demonstration for their submission, so they can come up with even better ones.
Mike, let's talk about the available materials that can be used for this experiment. Now, the contents of the Kids in Micro-G Experiment Challenge Supply Kit is available on the website. The supply kit contains clothing items, common hygiene and office supplies, food condiment packs including water, and a few other items typically seen in the science classroom. All these items, or items that are very similar, should be available in the student scientist classrooms or from their educators.
That's right, Nathan. All of these items are fairly common. The items used in the classroom to build the experiment do not need to be exact duplicates, but as similar as possible. In fact, part of the experimental analysis could be to discuss the differences between what the material available on the ISS versus what the student scientists had available in their classrooms, and how that might affect the outcome of the experiment.
It's a great idea, Mike. Hey, let's check out a couple of the science classroom type items such as these Earth, Moon, and Mars, and these gyroscope devices.
Yeah, it's good to represent the three major targets of human exploration: the Earth, the Moon, and Mars. These scale models give students a good idea of the relative sizes. Also, the students have a blue 4 feet by 6 feet Nomex backdrop available to them that has a calibrated grid. The use of this backdrop, along with the stopwatch timer, might offer some interesting possibilities.
So, Mike, tell me how this gyro exerciser and this gyro tube works.
Yeah, this is really neat principle, and it demonstrates kind of one of the physical principles, one of the things that we'd like to see in the student experiments. This is a gyroscope. It's a normal toy gyroscope, and if we pull a string on it and get it all spinning, this gyroscope will not want to move. Even in free space, it would be hard to move this around, and this ability of the gyroscope to want to point in the same direction all the time is really helpful for pointing our spacecraft. It's also very helpful for aircraft navigation, as well as
Gyro exerciser.
Gyro exerciser. The gyro exerciser has a gyroscope inside, which is just nothing but a ball that we get spinning really fast. And then if we try to put a few side forces on it, it's going to wobble because it didn't want to move to the side. And this wobbling motion actually helps us exercise our hands. So the gyroscopic principle is just a common physical principle, but it's useful here on Earth as well as in space.
Well, Mike, I'd say those items are very cool. Now, at this point, it's good to note that your experiment should only take about 30 minutes from start of the experiment to the very end of the experiment. Now, for planning purposes, student scientists should consider a timeline that allows 10 minutes to set up, 10 minutes to run the experiment, and 10 minutes to take down the experiment. The setup, run, and takedown times can vary, but the total time cannot exceed 30 minutes.
Absolutely, Nathan. 30 minutes is the absolute time limit. Our student scientists are busy with other studies in their classroom, and frankly, we're busy on board the ISS, so we don't want to take up any more time than that. But half an hour should be and enough time for a meaningful, exciting, excellent, and fun microgravity science experiment.